As the launch date for Starship Flight 9 is just a few days away, the one thing we're all waiting for most is probably the FAA launch license. However, things aren't going as expected. Just recently, the FAA revealed a new problem on Starship Flight 9 license. So, what problem has the FAA declared for SpaceX? Let's find out on today's episode of Alpha Tech. The third static fire test of Ship 35 was conducted successfully, as announced by the company on X, accompanied by stunning and fiery images. Starship completed a long-duration 6-engine static fire and is undergoing final preparations for the 9th flight test. After completing the test, Ship 35 has been moved back to the production site to be equipped with an additional payload. Meanwhile, Booster 14 has been placed on the Orbital Launch Mount (OLM) and has undergone several mini-tests to validate the launch operation systems. Looking at this progress, it's clear that Starship is nearly ready for its upcoming flight. Notably, maritime hazard warnings for sailors in all sea areas have been scheduled from May 21st, leading many to assert that this is the launch date for Starship. This assumption is entirely reasonable, or even accurate when considering the history of previous launches. However, things are not as straightforward this time. Historically, SpaceX submitted the IFT-7 report about a month after the incident, from January 16 to February 24, 2025, and the FAA closed that report a month later, March 28, 2025. If a similar timeline applies to IFT-8, incident on March 6, 2025, SpaceX could have submitted the report by early April, with the FAA closing it by early May. However, we are now in mid-May, and no report has been submitted, indicating a delay in the investigation process. Even if the FAA approves the launch within the next day or two, the launch cannot happen immediately. The no earlier than date of May 21st is only 6 days away. Meanwhile, SpaceX still needs to transport Ship 35 to the launch site, stack the vehicles, schedule road closures, and ensure temporary flight restrictions, TFRs, for U.S. airspace. These steps typically take a few days to a week, assuming no additional issues arise. Therefore, even if the FAA grants approval in the coming days, with the remaining logistical steps, it's highly unlikely that SpaceX will meet the projected launch date. Moreover, Elon Musk, the head of SpaceX, has not explicitly confirmed the launch date for Starship Flight 9. He only stated, just before the Starship flight next week, I will give a company talk explaining the Mars game plan in Starbase, Texas, that will also be live-streamed on X. This statement focuses on a speech about the Mars plan, with the Starship Flight 9 launch mentioned in passing, with a vague next-week time frame, indicating uncertainty about the exact date. So, what could the launch date be? Feel free to comment if you notice anything significant. And please give Alpha Tech a subscription if you haven't already. We'll provide daily updates to ensure you don't miss any news. But even if Flight 9 is delayed, thorough testing to ensure a successful flight is critical, and safety cannot be compromised for haste. As space enthusiasts, let's remain patient and await Starship Flight 9. After all, the launch schedule for Starship Flight 9 depends on SpaceX submitting the report and the FAA's review timeline. Let's wait for the latest updates from them. The launch will undoubtedly be a spectacular show, not only for its breathtaking visuals, but also for the power and bright future that Starship's capabilities promise. With Flight 9, SpaceX hopes to get the Starship program back on track. The company aims to conduct up to 25 Starship test flights this year, but it may not reach that number. The short-term goals following Flight 9 include returning Starship from low Earth orbit back to the launch site, using a catch tower similar to the one SpaceX has used to recover the Super Heavy booster. After that, SpaceX will begin flight testing of in-space refueling systems, transferring supercooled liquid fuel between 2 starships in orbit. This is a critical milestone for NASA, which has a contract worth more than $4 billion with SpaceX to develop a version of Starship that can land humans on the moon. To achieve this, SpaceX must launch about 10 Starship tanker vehicles, though the exact number is still uncertain, to refuel the lunar lander Starship before it can leave low Earth orbit. SpaceX founder Elon Musk also wants Starship to travel to Mars, which will also require mastery of in-space refueling, NASA may soon rely on Starship and other large commercial rockets to transport astronauts from Earth as well. The Trump administration once proposed canceling NASA's Space Launch System (SLS) rocket after 2 more flights in favor of lower-cost commercial alternatives. Before any of this becomes feasible, SpaceX must prove that it has overcome the challenges faced in the last 2 test flights. Wrapping up the news on Starship Flight 9, let's move on to equally exciting updates about the private spaceflight mission Axiom 4, with SpaceX as the main transportation provider. The debut of SpaceX's 5th and final Dragon spacecraft, identified by tail number C213, has encountered further delays, pushing back its readiness to support upcoming missions to the International Space Station, ISS. Originally slated to facilitate Axiom Mission 4, AX-4, the 4th private astronaut mission to the ISS, the C213 capsule, will not be prepared until at least June 2025. This development has prompted NASA and its partners to adjust the launch schedule, with AX-4 now targeting a launch no earlier than June 8, 2025, from Launch Complex 39A at NASA's Kennedy Space Center in Florida. The mission was previously scheduled for May 29, 2025, but ongoing challenges with the spacecraft's readiness necessitated the postponement. In a statement released on Wednesday, NASA explained the rationale behind the schedule adjustments, emphasizing the need for additional time to ensure mission success. After reviewing the International Space Station flight schedule, NASA and its partners are shifting launch opportunities for several upcoming missions, the agency noted. The schedule adjustments provide more time to finalize mission plans, spacecraft readiness, and logistics. This delay reflects a cautious approach to guarantee that all systems are fully operational, particularly given the critical role the C213 Dragon is expected to play in supporting both crewed and cargo missions to the ISS. The C213 Dragon spacecraft has faced a series of challenges that have impacted multiple missions over the past few years. In November 2022, Sarah Walker, SpaceX's Director of Dragon Mission Management, highlighted the company's efforts to complete the 5th cargo Dragon, describing it as a vital asset to carry us into the future and make sure we can support as many flights as our customers want to fly with us. At that time, Walker projected that the capsule would be ready by 2024. However, technical difficulties have repeatedly delayed its debut. By July 2024, SpaceX had planned to utilize C213 for the Crew 10 mission, initially scheduled for February 2025. This mission carried heightened significance, as it was tasked with transporting a crew to the ISS to relieve astronauts Butch Wilmore and Suni Williams, who were stranded due to issues with Boeing's Starliner spacecraft. However, SpaceX encountered significant hurdles with C213, including problems with its propulsion and environmental control systems, as well as a faulty battery that required replacement. The battery issue proved particularly complex, necessitating the disassembly of a substantial portion of the spacecraft. Faced with the prospect of a prolonged delay, NASA and SpaceX opted to reassign the Crew 10 mission to Dragon Capsule C210, which had originally been designated for the AX-4 mission as early as April 2024. This reshuffling underscores the cascading impact of C213's delays on NASA's tightly coordinated ISS mission schedule. In tandem with NASA's announcement of the AX-4 delay, Axiom Space, the Houston-based company overseeing the private astronaut mission, scheduled a mission overview news conference for Tuesday, May 20, 2025. The event will feature key figures, including Dana Weigel, NASA's ISS program manager, and Sarah Walker, offering insights into the mission's objectives and the steps being taken to address the ongoing challenges. The conference is expected to provide further clarity on the revised timeline and the measures being implemented to ensure the C213 Dragon's readiness. When AX-4 eventually launches, it will mark a significant milestone in private space exploration. The mission will involve a roughly 2-week stay aboard the ISS for a 4-member crew. NASA's announcement also provided updates on other upcoming ISS missions, reflecting the agency's efforts to maintain a robust schedule despite the C213 delays. The Crew 11 mission, a long-duration expedition to the ISS, remains on track for a launch no earlier than late July 2025. Additionally, SpaceX's 33rd Commercial Resupply Services, CRS-33 mission is slated for late August 2025. The CRS-33 mission will utilize a Dragon cargo spacecraft equipped with a specialized reboost kit, designed to deliver propulsive boosts to maintain the ISS's orbital altitude. This capability is particularly significant, as it will reduce the reliance on propellant from the Russian segment of the ISS and help preserve reserve levels, enhancing the station's operational efficiency. The ISS, a cornerstone of international space collaboration for over 2 decades, is nearing the end of its operational life, with plans for its retirement around 2030. As this deadline approaches, NASA and its partners are actively working to ensure a seamless transition to commercially operated space stations. Companies like Axiom Space are at the forefront of this effort, developing private orbital platforms to continue crewed research in microgravity. Axiom's vision includes launching its own space station modules, which could initially attach to the ISS before operating independently. The AX-4 mission, despite its delays, represents a critical step in building the expertise and infrastructure needed for this new era of commercial space exploration. Looking ahead, the successful debut of C-213 will bolster SpaceX's capacity to support an ambitious slate of ISS missions while paving the way for the company's contributions to future commercial space stations. For now, the space community awaits further updates from the upcoming Axiom Space News Conference and the eventual launch of AX-4, which promises to advance the frontiers of private space exploration and international cooperation in orbit. Starship's in-orbit refueling technology is becoming more real than ever. Many people may still be skeptical about this, especially since SpaceX is currently struggling with Flight 9 following 2 failed launches. How could they possibly be developing Starship's refueling system this quickly? But the fact is quite different. Recently, SpaceX revealed a very special component, what appears to be a newly upgraded version of the ship's refueling hardware. This is clear evidence that an in-orbit refueling test could take place in the near future. So, what exactly SpaceX upgraded in this technology? And when might we witness this historic demonstration of in-space refueling? Recently, an unusual Starship rocket component was spotted at Starbase. With its round steel frame and what appears to be a larger diameter than the current Starship, the component seems to be part of a newly designed refueling system now being moved into place at the production site. The equipment includes a metallic quick disconnect (QD) faceplate, featuring 2 large circular structures likely designed as alignment or locking mechanisms to ensure a secure and precise connection during propellant transfer. As we can see, this design reveals a shift towards separating the liquid oxygen (LOX) and liquid methane (CH4) connections into individual QD plates, an evolution from earlier, more unified configurations. This modular approach, similar to the updated Orbital Launch Mount OLM, now used for the booster version 2, reflects a broader upgrade effort from the rocket itself to the supporting ground infrastructure. And with these visible changes, they are expected to have significant implications for Starship's in-orbit refueling capability. First and foremost, it enhances thermal and structural isolation between the 2 cryogenic fluids, which differ significantly in temperature and handling requirements. This separation reduces thermal interference and makes it easier to manage boil-off and insulation, which are critical during prolonged orbital operations. Second, it simplifies mechanical design and maintenance, allowing engineers to optimize each interface for the specific fluid it handles, rather than compromising with a shared system. This can lead to higher reliability and safety, especially when operating autonomously in orbit, where quick disconnects must mate and seal perfectly without human intervention. Third, the modular approach supports parallel development and testing, allowing SpaceX to iterate and refine LOX and CH4 systems independently. With everything mentioned so far, we're clearly seeing signs of what could be Starship's first in-space refueling test. And why not? Are you worried that recent issues with the Starship upper stage during Flights 7 and 8 might delay the program's development? Well, that concern is understandable, but rest assured, SpaceX has never stopped pushing forward to improve its rocket. In preparation for a successful Starship Flight 9, SpaceX engineers have been working around the clock to implement the best possible upgrades to the Starship 5-2 and its engines. If failure is not an option, then success must be achieved through relentless effort. And progressing toward a demo flight to transfer propellant from one Starship to another is not just important, it's a necessity, expected to happen sometime in 2025 or at the latest, the summer of 2026. Back in late 2024, during internal meetings with SpaceX, NASA repeatedly emphasized the transformative potential of Starship in revolutionizing commercial spaceflight. Most critically, the agency is counting on the vehicle to return humans to the moon through the Artemis program. NASA has awarded SpaceX a $4.05 billion contract for 2 crewed Starships, one of which will land astronauts on the moon for the first time since the Apollo era. Because of this, NASA originally expected SpaceX to demonstrate in-space propellant transfer by early 2025. However, with the delay of Artemis II pushing Artemis III into 2026, this demonstration timeline likely shifted as well. On top of that, Starship has not yet achieved fully stable flight performance, which makes an immediate demo unrealistic. But make no mistake, SpaceX is moving toward this historic milestone, and the recently spotted component at Starbase marks the first tangible step in that direction. So, when exactly might this historic test take place? Given SpaceX's current pace, the earliest likely timeframe for a Starship-to-Starship refueling demonstration would be late 2025, even though the actual hardware needed could be completed within just a month or two. Some might worry that SpaceX doesn't have enough time to conduct the required number of launches in the next 7 months, but I'm confident they can pull it off. SpaceX is manufacturing dozens of new rocket components right now, so hardware supply won't be the bottleneck. As for regulatory hurdles, particularly FAA launch licenses, SpaceX isn't overly concerned. The FAA recently approved up to 25 Starship launches per year. More importantly, if future flights proceed smoothly, SpaceX may not need to apply for a new license for each launch, allowing rapid-fire test flights to build reliability and pave the way for that epic, safe, and game-changing fuel transfer demo. And now, it's time we learn more about the demonstration that could shake the spaceflight world when it finally happens. In-space refueling is far from a simple task. Microgravity complicates the movement of liquids, requiring innovative solutions to connect spacecraft and transfer propellant while in orbit, something that has never been done before. Several potential methods are being explored, including using pumps or taking advantage of pressure differentials between tanks. The successful handling of liquid methane during the IM-1 and IM-2 missions has provided valuable insights, but actual fuel transfer between 2 separate spacecraft still needs to be demonstrated through multiple test flights. At present, there are a few approaches SpaceX might use. The first involves using pumps. The second takes advantage of the spacecraft's motion to help move the propellant. The third, simpler and most likely to be adopted, relies on pressure differentials between the 2 spacecraft to drive the fuel transfer. Once this capability is proven, another major challenge for SpaceX will be launching a fleet of Starship tankers to refuel the primary Starship in orbit. These tanker flights must happen in quick succession, requiring a large number of Starship prototypes and multiple launch pads to support the launch and landing cadence of booster stages. But SpaceX has good reason to be confident in its progress. In addition to mastering liftoff and early-stage return, the company has already demonstrated liquid fuel handling in space once, during Flight 3's tipping point test, where propellant was transferred from a header tank to the main tank within the same vehicle. While this isn't the same as transferring fuel between 2 separate spacecraft, it still represents a foundational step. To refuel in space, Starship will need to meet 3 critical and essential conditions: establishing connections in orbit, maintaining propellants at cryogenic temperatures, and transferring fuel between spacecraft. Each of these challenges must be overcome to ensure the success of long-duration missions beyond Earth's orbit. First is docking. This is perhaps the most straightforward of these challenges, given SpaceX's extensive experience with docking operations at the International Space Station, ISS. Starship's refueling operations will involve docking 2 massive spacecraft in orbit, one acting as the tanker and the other as the depot or mission vehicle. While Starship is significantly larger than current spacecraft, the docking process benefits from the fact that SpaceX controls both vehicles, allowing for precise alignment and engagement systems. SpaceX's history of successfully docking cargo and crew vehicles to the ISS provides a solid foundation for these operations. Next is propellant cooling. This presents a more intricate challenge, particularly due to the cryogenic nature of the fuels involved. Starship uses liquid oxygen, LOX, and liquid methane, which need to be kept at extremely low temperatures, 90.2 Kelvin for LOX, and 112 Kelvin for methane. Maintaining these temperatures in the vacuum of space, where heat can't easily dissipate, is difficult. The risk is that without proper cooling, the propellant could boil off, reducing the mission's fuel supply. To address this, SpaceX is exploring passive cooling techniques, such as specialized surface coatings and controlled spacecraft orientation to minimize solar heating. Additionally, NASA's research into cryogenic fluid management, including the use of cryocoolers, provides valuable insights. Cryocoolers are advanced refrigeration systems that can prevent boil-off by maintaining the propellant at stable, ultra-cold temperatures, as demonstrated in applications like MRI machines and space missions. Finally, propellant transfer in microgravity is another significant hurdle. On Earth, gravity naturally separates liquid from gas in a tank, but in space, without gravity, propellants tend to float freely, making transfer difficult. To address this, techniques like ullage thrusters are used. These small thrusters create a slight acceleration, pushing the liquid fuel to the bottom of the tank so it can be pumped out effectively. Another proposed method involves cooling the receiving tank so that the pressure difference forces the propellant from one tank to another, a technique NASA has successfully tested in ground-based experiments and partially in space with missions like the robotic refueling mission RRM-3. NASA's historical and ongoing research into cryogenic propellant management underpins much of the current understanding of these technologies. The RRM-3 mission, flown to the ISS in 2018, successfully demonstrated long-term cryogen storage, although a hardware failure prevented the demonstration of in-orbit methane transfer. Despite this, the mission validated key concepts needed for orbital refueling, such as zero boil-off storage, showing that with continued development, these technologies are viable for future missions. Overall, the technical challenges of orbital refueling are formidable but not insurmountable. With SpaceX's approach, their rockets can leverage proven techniques while also advancing the level of sophistication in space operations. However, there are still many questions regarding the number of tanker flights needed for SpaceX's Starship missions, with estimates ranging from as few as 5 flights to as many as 20 or more. This variation stems from several factors, including the payload capacity of each tanker, the mass of the lunar Starship, and the specific mission requirements, such as the amount of cargo being delivered to the Moon or left behind on the lunar surface. While the exact number remains uncertain, what is clear is that the success of this approach hinges on SpaceX's ability to conduct these flights efficiently and reliably. In scenarios where only 5 tanker flights are needed, the refueling process appears straightforward and manageable, even with current technologies. This lower number assumes high efficiency in both payload delivery and propellant usage, potentially achievable if Starship's design meets or exceeds expectations. However, in more conservative estimates, where up to 20 flights may be required, the challenge becomes significantly more complex. Conducting 20 tanker flights within a tight mission timeline demands a high level of operational capability and reliability from SpaceX. Each additional flight introduces more opportunities for delays or failures, which could jeopardize the entire mission. Despite these challenges, SpaceX's strategy of rapid reuse is designed to mitigate the risks associated with a higher number of tanker flights. Starship and its booster, Super Heavy, are being developed with rapid turnaround times in mind, aiming for a level of reusability that far surpasses any current space vehicle. If SpaceX can achieve its goal of launching and landing the same Starship multiple times within days or even hours, the logistical burden of multiple tanker flights becomes much more manageable. For example, in a scenario where 20 flights are required, SpaceX's vision of quick reusability could allow for a launch every few days. significantly reducing the time and cost associated with each mission. Moreover, the economics of SpaceX's reusable launch system are designed to accommodate frequent flights without a proportional increase in cost. The key advantage of this approach is that the cost of propellant, already relatively low, does not scale significantly with the number of flights. Instead, the focus shifts to the efficiency of launch operations, where SpaceX has already demonstrated considerable proficiency with its Falcon 9 program. The ability to launch multiple Starship flights in quick succession could make even a high number of tanker flights feasible, both technically and financially. SpaceX is the most revolutionary company in the world today. They've pulled off the impossible, creating reusable rockets, a feat once thought out of reach by even the world's top scientists. They made history as the first private company to send astronauts to the International Space Station. They've just launched a new era with Starlink, revolutionizing satellite internet. And that's just a small part of their achievements over the past 2 decades. Even if you think that's truly impressive, SpaceX is still working on something even more surprising. And their latest move with the new Starship landing method will blow your mind. SpaceX is exploring a bold new approach to Starship landings that could completely change the way we think about recovery operations. The idea is to use an offshore drone ship for landings, reducing reliance on Mechazilla. Even more importantly, the latest FAA reports are encouraging SpaceX to adopt this floating platform method to minimize risks and ensure infrastructure safety. Then, in February, something curious happened that stirred even more speculation around SpaceX's recovery plans. Specifically, during this time, an old Navy aircraft carrier, the USS John F. Kennedy CV-67, was spotted cruising past SpaceX's starbase in Boca Chica, Texas, as it made its way to the port of Brownsville, just 15 miles northwest of the launch pad. Sure, that might not sound like a big deal, but this isn't just any ship, and it's showing up awfully close to SpaceX's turf. It didn't take long for the rumors to start flying. Could Elon and his team have something up their sleeve? In the past, SpaceX also purchased 2 old oil rigs with plans to transform them into floating launch platforms for Starship. When a giant retired Navy ship shows up nearby, folks can't help but wonder, is there more to this story? What is it about this ship that might catch SpaceX's eye? Well, let me break it down for you. This isn't just some rusty old vessel. We're talking about a full-blown, multi-role aircraft carrier built for Navy combat operations. The ship was launched back in 1967, and after nearly 39 years of service, she officially retired in 2007 at Mayport, Florida. It's only now, in 2025, that the Navy is finally moving forward with the final steps to dismantle her. It'd be a real shame to scrap a ship like that. Instead, SpaceX might be eyeing it as a massive floating platform, perfect for landing a Starship. Whether it's the second stage or the giant Super Heavy booster, this thing could handle it. There are actually 2 possible landing concepts being floated around. The first, and simplest idea, Starship comes down using its landing legs. SpaceX already nailed that tech with Falcon 9 and Falcon Heavy, but Starship is on a whole different scale. It's bigger, heavier, and more powerful. That means it needs a much tougher structure underneath when it lands. To put it in perspective, a Starship could still weigh anywhere from 80 to 100 tons during landing. And the Super Heavy booster? We're talking over 200 tons. So, yeah, you need one heck of a sturdy deck to handle that kind of mass. And guess what? The USS JFK could totally carry that kind of load. With a length of 1,052 feet, a width of 252 feet, and a displacement of around 87,000 tons when fully loaded, this ship is built to carry some serious weight. It could fit up to 80 aircraft and accommodate around 5,000 people. So it's not too far-fetched to imagine it holding up to 5 Starship prototypes on a single landing. That would be a game changer, completely revolutionizing recovery operations for SpaceX's vehicles. Of course, using this method would only be feasible once SpaceX finishes researching and testing the landing leg integration system for Starship stages, something they need to do to avoid depending on Mechazilla. With critical missions like Artemis 3 set for 2027, SpaceX needs to have the landing legs ready and tested well before embarking on future missions to destinations like the Moon or Mars. The The second landing method involves installing a simple catch tower directly on the USS JFK's surface. This would allow Starship to land vertically using the Mechazilla arm, similar to the plans for Starbase. Given the platform's weight capacity, theoretically, it could support both the weight of the catching arm and the Starship itself during landing. Thanks to its massive size and low center of gravity, the ship is capable of withstanding up to a Category 5 storm, making it suitable for operations in harsh oceanic weather conditions. So, landing using a system similar to the launch tower is certainly a viable option. However, this method would require significant additional infrastructure, tank farms, OLM, launch towers, and water deluge systems, making the setup process time-consuming. That's why, for now, landing using legs seems to be the better option. Well, the USS John F. Kennedy reminds me of when SpaceX bought 2 offshore oil rigs to test Starship landings in 2020. Back then, SpaceX bought 2 deep-water oil rigs that were previously owned by offshore drilling company Valaris. Reports showed that they sold the rigs for $3.5 million each, just before the company filed for bankruptcy. So, Elon got a great deal on a pair of massive offshore platforms. Both rigs were semi-submersible platforms with a main deck size of about 240 by 255 feet. They didn't sit on the ocean floor. Instead, they floated on large pontoons submerged below the surface to boost stability. They were anchored in place with mooring lines connected to the seabed. The rigs used a computer-controlled ballast system to maintain balance, keeping them steady even in rough weather conditions. In theory, it sounded like a pretty awesome platform for launching rockets, and that was exactly the idea at SpaceX. The original plan was to convert these rigs into launch and landing platforms for Starship. They even gave them names, Phobos and Deimos, after the 2 moons of Mars. But by early 2021, news about the 2 rigs started to fade from the headlines, and not many people kept up with what happened to them. The reason? SpaceX went quiet for a while, focusing on converting them into rocket launch platforms. These rigs were originally built for oil drilling, so they were covered in towers, crew quarters, and all sorts of other structures. That meant all the existing infrastructure had to be stripped away before any real progress could happen. By mid-2021, the deck of Phobos had been partially cleared, and work on Deimos had started around the same time. However, by early 2022, work on both rigs suddenly came to a halt. It wasn't until February 2023 that SpaceX finally released a full update on the floating launch platforms. And, unfortunately, it wasn't good news. At the Commercial Space Transportation Conference hosted by the FAA, SpaceX President Gwynne Shotwell revealed that the company had sold the 2 offshore rigs after determining they weren't suitable for launch operations. "We bought them. We sold them. They were not the right platform," she said, without disclosing when the sale took place or who the buyer was. Shotwell explained that SpaceX needed more real-world experience flying Starship before pursuing offshore platforms. "We really need to fly this vehicle to understand it, to get to know this machine, and then we'll figure out how we're going to launch it. This might just be the perfect time to turn that past project into reality with the USS JFK. Whatever happens next, it's clear SpaceX isn't done surprising us. While the idea of using offshore platforms might sound futuristic, SpaceX isn't the only company exploring this approach. Blue Origin, Jeff Bezos' aerospace company, announced plans early on to recover its New Glenn rocket using a drone ship, aiming to catch up with SpaceX's reusability strategy. The goal? Lower launch costs and boost access to space, a playbook SpaceX has already nailed with Falcon 9 and Falcon Heavy. From the start, Blue Origin emphasized that New Glenn's first stage would be reusable, designed to land vertically on a moving platform about 620 miles out in the Atlantic, rather than crashing into the ocean. This ambitious approach mirrors how Falcon 9 returns to its drone ships. Their recovery vessel, seen as a crucial step toward making New Glenn truly reusable and competitive, was even given a meaningful name, Jacqueline, in honor of Jeff Bezos' mother. Bezos spent a lot of time hyping it up, presenting it almost as the backbone of their rocket recovery operations. Blue Origin claimed that Jacqueline would be outfitted with state-of-the-art stabilization systems to handle the intense heat and thrust during New Glenn's landing, ensuring a safe and precise touchdown. Despite all the bold promises, Jacqueline never got to catch a rocket. The entire plan was scrapped in 2022, and the ship was quietly dismantled, leaving its potential unrealized. For the next 2 years, there were no updates about Jacqueline, no landing systems were installed, and no booster ever touched its deck. The company never provided a clear technical explanation for the sudden cancellation of the project. Perhaps the ship encountered serious technical issues, which is why they kept quiet for so long. But in 2024, Blue Origin shocked everyone by unveiling a new recovery vessel, also named Jacqueline, or Landing Platform Vessel 1, specifically designed for New Glenn. This new vessel went into operation in 2024, signaling a new chapter for the project. The new Jacqueline vessel is a massive 380 feet by 150 feet and is equipped with significantly more advanced stabilization systems compared to its predecessor, designed to ensure safe landings even in rough seas. Blue Origin tested the recovery process with a first stage model in August 2024 at Port Canaveral, Florida, to confirm the procedures and tools ahead of the first flight. New Glenn's maiden flight took place on January 16, 2025, but we didn't get a chance to see Jacqueline in action. Unfortunately, during this flight, the first stage was lost during its landing attempt on Jacqueline, although the primary mission, placing the upper stage into orbit, was successfully completed. Yeah, it's kind of ironic. While SpaceX has been landing Falcon boosters on drone ships in the ocean without breaking a sweat, Blue Origin is still talking about what they could do someday. And even now, months later, there's been no real progress toward their next test flight. The effort to create Jacqueline clearly shows that Blue Origin was influenced by SpaceX, which has been using drone ships like Just Read the Instructions and Of Course I Still Love You to recover Falcon 9 boosters since 2015. However, Blue Origin faces a bigger challenge since New Glenn is much larger and heavier than Falcon 9, requiring a larger recovery vessel and more complex landing technology. Still, Blue Origin's persistence with its reusability plan highlights their ambition to directly compete with SpaceX in the heavy lift market, especially as New Glenn is designed for at least 25 flights per first stage. To sum it up, if SpaceX uses the USS JFK-CV-67, it could save money on developing a new drone ship and offer extra benefits, like transporting Starship between Texas and Florida if they build another launch site. It's a far better move than Blue Origin's quiet work on Jacqueline, which never really panned out. The Jacqueline fiasco is a clear example of the gap between vision and execution. Neutron, Rocket Lab's newest rocket set, to debut in late 2025, is emerging as a new bright spot in the space launch industry following SpaceX's Starship. Although not a heavy-lift vehicle like Starship, Neutron's medium-lift capability has still caught the attention of U.S. policymakers due to its promising development potential in the near future. Recently, Rocket Lab's Neutron rocket was assigned to the U.S. Air Force Research Laboratory's AFRL Rocket Cargo Program, tasked with point-to-point cargo delivery. This marks the beginning of a new era in commercial launch capabilities aimed at enhancing global defense logistics. The launch contract will see Neutron execute a rocket cargo survivability experiment under the AFRL Rocket Experimentation for Global Agile Logistics Regal Solicitation, an effort by the Department of Defense to create a rocket-based point-to-point transportation system to quickly and rapidly deliver cargo around the world with commercial launch providers. AFRL's experiment will be launched by Neutron and re-enter Earth's atmosphere in a demonstration of re-entry capability for future Regal missions. Rocket Lab's Neutron medium-lift, reusable launch vehicle will provide both government and commercial customers with an alternative and reliable launch service capable of deploying 13,000 kilograms to low Earth orbit. Neutron is tailored to deploy constellations and national security missions, as well as science and exploration payloads. In addition to serving customers with greater affordability in the medium launch market, Neutron is key to Rocket Lab's strategy as an end-to-end space company preparing to deploy its own constellations and deliver services from space in the future. Rocket Lab founder and CEO Sir Peter Beck says, "Neutron is a powerful new launch option that will set a new standard for performance, affordability, and reliability for government and commercial space users in medium launch." This opportunity for the U.S. Air Force not only helps to advance space logistics, It also demonstrates a high degree of confidence by the DoD in Neutron's capabilities. Anticipation is high for Neutron's inaugural flight this year, and we're excited to showcase Neutron as a platform for R&D for point-to-point logistics for the DoD. Additionally, Rocket Lab's CEO, Peter Beck, highlighted the company's selection for the National Security Space Launch, NSSL, Phase 3 Lane 1 program as the quarter's most significant achievement. Announced on March 27th by the Space Systems Command, Rocket Lab and Stoke Space earned the opportunity to compete alongside industry giants Blue Origin, SpaceX, and United Launch Alliance, ULA, for national security launch contracts. The NSSL Phase 3 Lane 1 program operates under an indefinite delivery, indefinite quantity contract, enabling selected companies to bid on launch service task orders through 2029. With at least 30 missions anticipated, the program is expected to award task orders worth approximately $5.6 billion. Beck described the selection as a tremendous vote of confidence from the Pentagon, emphasizing Rocket Lab's unique position as the only publicly traded company to join the NSSL program. Following this milestone, Rocket Lab secured a $5 million task order to conduct initial mission assurance reviews. Beck noted that the company has already held a kickoff meeting with key government partners, including the U.S. Space Force's Assured Access to Space Office and the National Reconnaissance Office's Office of Space Launch. He added that Rocket Lab will begin bidding for additional task orders once the Neutron rocket completes its inaugural launch. Neutron is in a strong position to meet medium-lift launch demands for future commercial and government missions. Designed to deliver up to 13,000 kilograms or 13 metric tons to low Earth orbit in its reusable configuration, Neutron fills a critical niche between smaller launch vehicles like Rocket Lab's Electron and heavy-lift systems, such as SpaceX's Starship. Its 7-meter payload fairing and reusable first stage make it especially well-suited for satellite constellation deployment, national security payloads, and innovative applications like point-to-point cargo delivery. Significant progress is being made at Neutron's dedicated launch site, Launch Complex 3, located at the Mid-Atlantic Regional Spaceport on Wallops Island, Virginia. The site has just been completed, and recently Peter Beck shared on X the first activation of the launch pad, announcing that the site will soon be open. High-quality videos and stunning perspectives show that Rocket Lab is doing excellent work, steadily moving toward Neutron's first integration and testing milestones. This state-of-the-art facility is designed to support high-frequency launches, featuring a robust launch pad, integration facilities, and infrastructure customized to accommodate Neutron's reusable architecture. Its strategic location on Wallops Island provides access to a wide range of orbital inclinations, making it ideal for government missions, including those from the Department of Defense and NASA, as well as commercial satellite launches. On the production and testing front, Rocket Lab is scaling up its infrastructure and advancing key components of the Neutron program across its U.S. facilities. In early April, the company completed a comprehensive round of tests on Neutron's second stage. These included high-pressure tests, mechanical stress evaluations, and validation of both systems and software. The stage passed all tests successfully, marking a crucial milestone on the path to the rocket's inaugural flight. Uniquely, Neutron's second stage will be tucked inside the first stage, which is designed with a nose that opens. The concept is that once a Neutron reaches a certain point in flight, the first stage will open its nose cone, release the second stage along with its payload, then close up and return to Earth, while the second stage ignites its engine to deliver the cargo to its target orbit. Besides, the Archimedes engine, a reusable liquid oxygen and methane engine designed specifically for Neutron, is undergoing rigorous testing at Rocket Lab's test facilities, including the company's site in Stennis, Mississippi. These tests validate the engine's performance, reliability, and reusability, which are central to Neutron's cost-competitive design. Full-scale components, such as the rocket's composite airframe and tank structures, are also being tested to ensure they meet the structural and thermal demands of launch and re-entry. Rocket Lab's production facilities in Long Beach, California, and other sites are scaling up to support Neutron's manufacturing needs, leveraging the company's experience in the high-rate production of Electron rockets to streamline processes and reduce costs. The Neutron program's momentum is further bolstered by Rocket Lab's proven track record with Electron, which has completed over 60 launches and established the company as a leader in small satellite deployment. Lessons learned from the Electron's rapid iteration and operational cadence are being applied to Neutron, ensuring a disciplined approach to development and risk mitigation. The company's focus on reusability, with plans for the first stage to return to Earth for refurbishment and relaunch, positions Neutron to compete on cost with larger providers while offering tailored solutions for medium-lift payloads. With its first launch on track for the second half of 2025, Neutron is set to expand Rocket Lab's market reach, capturing opportunities in satellite constellation deployment, deep space missions, and novel applications like space-based cargo delivery. That's why it's well-deserved that Rocket Lab's Neutron has secured a contract with the AFRL. But when it comes to point-to-point cargo transport, something about this feels familiar. That's right, SpaceX's Starship also received a contract from the U.S. Air Force for point-to-point delivery. Both initiatives fall under the AFRL's broader vision to utilize reusable commercial rockets for global cargo delivery, capable of transporting payloads comparable to those of a C-17 cargo aircraft anywhere in the world in under an hour. This capability is aimed at supporting both military logistics and humanitarian aid by delivering cargo to remote or austere environments, bypassing the limitations of traditional air and sea transport. Rocket Lab and SpaceX are both tasked with investigating innovative trajectories and landing systems to ensure adaptability across diverse operational scenarios, aligning with the Department of Defense's goals of acquiring cost-effective, commercially driven space logistics solutions. Despite these similarities, the contracts differ notably in structure and scope. SpaceX was awarded a $102 million 5-year contract in January 2022, the largest under the rocket cargo program, to demonstrate a full range of point-to-point capabilities. This includes designing cargo bays compatible with USTRANSCOM's intermodal containers, developing landing systems suitable for various terrains, and potentially performing a large-scale demonstration of heavy cargo transport by 2026, leveraging Starship's massive 100-ton payload capacity. Looking at the broader picture, Starship is significantly ahead of Neutron. It has already completed multiple test flights and demonstrated capabilities unmatched by any other launch system to date. Furthermore, SpaceX has been actively collecting environmental and performance data during its commercial flights. These efforts bring Starship closer to full operational readiness, with its contract emphasizing rapid loading, unloading, and integration with military logistics systems. In contrast, Neutron remains in the development phase, with its maiden flight scheduled for 2025. Its planned mission in 2026 is expected to be a focused test rather than a full operational demonstration. Initially unveiled in March 2021, Rocket Lab announced plans for Neutron to take to the skies by 2024. By December 2021, Rocket Lab refined its design, opting for a return-to-launch site strategy over the previously considered floating platform recovery, which was seen as a more cost-effective and operationally simpler approach. As 2022 progressed, the construction of Neutron's launch site at Wallops Island, Virginia, began, alongside the development of manufacturing facilities to support the rocket's complex carbon composite structures. By early 2024, Rocket Lab had to publicly acknowledge that Neutron's first flight would not meet the 2024 deadline. Instead, during an earnings call in February, the company optimistically set a new target for a launch by the end of 2024, citing progress on avionics, structures, and launch pad construction. This schedule was described as a green light scenario, meaning everything had to go perfectly for this timeline to hold. However, skepticism persisted, especially as hot fire tests of the Archimedes engines, critical for validating the rocket's performance, were still pending. The situation escalated in May 2024, when Rocket Lab officially announced that Neutron's first flight was now expected no earlier than mid-2025. This delay was not attributed to any specific technical issue, but rather to the complexities inherent in bringing a new launch vehicle to operational status. The competitive landscape adds another layer of complexity. Neutron must prove its worth not only against SpaceX's reusable Falcon 9, but also against emerging players like Firefly Aerospace and established international competitors. The market for satellite launches is becoming increasingly crowded, with mega-constellation projects demanding efficiency and reliability at scale. Neutron's design caters to this demand, promising to deploy multiple satellites into specific orbital planes. But the proof will be in its performance and cost-effectiveness. Rocket Lab's strategy with Neutron extends beyond just launching satellites. It's about positioning itself as a comprehensive space solutions provider. The company has secured contracts for Neutron launches, including a multi-launch deal with an undisclosed client, signaling confidence in the rocket despite the controversies. Yet, the path to operational success is fraught with technical challenges, market saturation, and the ever-present risk of unforeseen setbacks. Whether Neutron is the new frontier or a flight to nowhere remains a narrative in the making, watched closely by an industry that values both innovation and reliability. The real test will come not just with Neutron's first flight, but in its ability to compete, adapt, and thrive in an industry where only the most resilient and innovative survive. The stakes are high, and all eyes remain on Rocket Lab's next moves. Definitely many of us have heard of the Long March 9 rocket, introduced by China. This rocket is designed to be reusable and is widely considered to be a blatant copy of SpaceX's Starship. And the imitation doesn't stop at the exterior. China is reportedly attempting to replicate the internal structure of Starship as closely as possible. Recently, the China Academy of Launch Vehicle Technology, CALT, a key institution under the state-owned China Aerospace Science and Technology Corporation, CASC, responsible for developing this rocket, publicly showcased for the first time the internal manufacturing process of a rocket that many argue is a copy of another. In late March and April 2025, CALT announced the successful construction of two massive propellant tanks, with diameters of 5.0 meters and 10.6 meters, respectively. These tanks are designed to store cryogenic propellants for space-bound rockets. While the 10.6-meter tank is clearly associated with the Long March 9, the purpose of the 5.0-meter tank remains unclear. CALT is also developing the Long March 10, a 5.0-meter diameter rocket intended for manned lunar missions, but it's uncertain whether this stainless steel tank is meant for a reusable version of the Long March 10 or for a completely different project. Either way, one of these tanks will eventually be part of an actual rocket, whether for testing or operational launch. Traditionally, rocket fuel tanks are made of aluminum alloys due to their light weight, strength, and well-established performance for cryogenic fuel storage. However, when SpaceX entered the market, they went against convention and chose stainless steel for the construction of their rockets, inside and out. As a startup at the time, SpaceX explained that stainless steel offered multiple advantages. It was cheaper, had a higher melting point, and provided thermal protection benefits for storing cryogenic fuels. Chinese rocket engineers seem to agree, so much so that they've followed SpaceX's lead by also manufacturing not just their tanks, but potentially their entire rocket using stainless steel. That's why, when their first tanks were completed, they made a point of announcing it publicly. On April 29th, CALT declared this accomplishment as a major breakthrough in the development of large-diameter stainless steel structures. But the declaration felt almost absurd. It was essentially the announcement of a replica, not an original innovation. For some unknown reason, the official statement was taken down shortly afterward, but what it revealed was clear. China is highly confident in its openly imitative rocket project. This confidence is backed by significant government interest. The presence of senior officials from CALT, the China National Space Administration, CNSA, and other key agencies at the prototype unveiling ceremony underscored the strategic importance of this project. It seems this rocket is being groomed as China's best hope to compete directly with the U.S. Starship on the global stage. So, what will this rocket ultimately look like? Based on the latest specifications, the Long March 9 rocket will feature a fully reusable first stage powered by 30 YF-215 engines. These are full-flow stage combustion engines fueled by methane and liquid oxygen, each producing about 200 tons of thrust. For comparison, The first stage of SpaceX's Starship is powered by 33 Raptor engines, which also run on methane and liquid oxygen, but each produces around 280 tons of thrust. In fact, these specifications are recent updates, adjusted as SpaceX's Starship continues to evolve through its testing campaign. About a decade ago, when Chinese space officials first revealed their design for a super heavy launch vehicle, it looked much more conventional. That earlier version was fully expendable, with 3 stages and solid rocket boosters strapped to its sides. Now, the new specifications show a fully reusable configuration, with an upper stage that looks strikingly similar to Starship's second stage, complete with grid fins in the same positions. According to a presentation at an air show, China plans to fly this vehicle for the first time in 2033, nearly a decade from now. This super heavy rocket is expected to play a crucial role in China's plans to build the International Lunar Research Station, ILRS, during the 2030s. It will also be vital for ambitious projects like a space-based solar power station in geostationary orbit. A reusable rocket would dramatically cut launch costs and increase the long-term feasibility of such missions. China is also planning to construct at least 2 massive low-Earth orbit satellite constellations, each consisting of about 13,000 satellites. A fully reusable Long March 9 with high payload capacity would be highly beneficial for deploying these satellites, just as SpaceX plans to use Starship to launch its Starlink satellites. Of course, this isn't the only time China's space program or its emerging space startups have been caught copying SpaceX designs. In 2021, a promotional video from the China Academy of Launch Vehicle Technology, CALT, clearly replicated SpaceX's original concept, led by Elon Musk for an interplanetary transport system using Starship, which was then still called BFR. By 2022, yet another suspiciously familiar design appeared. A 2-stage launch system powered by liquid methane, once again closely resembling Starship. Chinese aerospace company Cosmo-Liap even released a promotional video copying SpaceX's concept of a launch tower with chopstick arms designed to catch the reusable first stage. Similarly, another Chinese startup, Space Pioneer, announced plans late last year to develop a rocket almost identical in design to SpaceX's reusable Falcon 9. These examples point to a trend. China's space sector appears to be suffering from a lack of original innovation, focused instead on chasing global competition through imitation. Of course, it's nothing new for Chinese industries to replicate or, in some cases, outright steal ideas from Western competitors. That said, it's at least worth acknowledging that China's space industry recognizes the future of space travel lies in reusability. Even the country's state-owned enterprises are now shifting their strategies toward that goal. In contrast, U.S. policymakers still seem reluctant to let go of NASA's aging, hyper-expensive, fully expendable Space Launch System, SLS. If the agency continues to rely on SLS, it could drain a budget that would be far better spent on game-changing technologies capable of propelling America's civil space program ahead of China. NASA and China's space agency are now locked in a new space race, each building international coalitions to explore the moon's south pole and ultimately establish permanent bases there. With real estate near the lunar south pole, especially around craters potentially containing ice, being limited, winning this race is crucial for long-term ambitions in space. For its initial lunar missions, China plans to use a more conventional rocket, the Long March 10. These early missions will last only a few days, but for sustained lunar operations, China is betting on the far more powerful and reusable Long March 9. If the ultimate goal is to build settlements on the moon, the real winner won't be the first nation to land astronauts. It will be the first to develop a fully reusable super heavy rocket and fund a program that makes the most of that revolutionary capability. For now, the U.S. holds the lead, thanks to Starship, which is already flying. But the race is far from over, and China's latest Long March 9 design shows that they know exactly where the finish line lies. By the end of 2025, at least 6 Chinese reusable rockets are expected to fly at an unprecedented pace for the country's private aerospace sector. These milestones are not isolated. They are backed by significant infrastructure upgrades, such as China's first dedicated commercial launch pad, which is scheduled to become operational in November 2024. These developments reflect a clear strategic pivot. China wants space autonomy. For years, the nation has sought to reduce dependence on Western technologies across sectors, from semiconductors to artificial intelligence, and the space industry is no exception. The current geopolitical landscape, including tensions with the U.S., has only accelerated this push for technological self-reliance. In a notable gesture of support, Chinese President Xi Jinping met with a group of tech entrepreneurs in February, encouraging the private sector to take a leading role in innovation. Among those present was the head of Galaxy Space, a rising satellite manufacturer seen as a Chinese counterpart to Starlink. The government's stance is clear. While state-owned aerospace giants like CASC and CALT remain important, they alone cannot sustain the momentum or pace needed to compete with the likes of SpaceX. This acknowledgement marks a shift in China's traditionally top-down approach to strategic industries, and a bet that the free market can turbocharge technological advancement. SpaceX remains the undisputed leader in the global space launch industry. As of late 2024, the company accounted for more than half of all orbital launches, completing 134 successful launches in that year alone. This includes a growing number of Starlink missions, which have put over 7,000 satellites into orbit, enabling near-global internet coverage. Its partially reusable Falcon 9 rocket continues to lower launch costs, with its first stage capable of flying over 24 times. In October 2024, SpaceX achieved a historic feat by recovering its Super Heavy booster during a Starship launch. And although the upper stage was lost during a subsequent test in March 2025, the rate of progress remains unmatched. Even Chinese analysts and aerospace entrepreneurs admit that SpaceX is years ahead. Yet, the American company has also served as a North Star for China's private space sector. According to Huo Liang, founder of Deep Blue Aerospace, SpaceX is a mentor to the industry. His company, like many others in China, is actively attempting to replicate and improve upon the reusable launch systems that have made SpaceX so cost-effective. Chinese private companies like Landspace, Orion Space, and Deep Blue Aerospace are rapidly developing their own reusable rockets. For example, Deep Blue Aerospace plans to recover the booster of its Nebula 1 rocket after a full orbital launch, a major step toward vertical reuse. Even more ambitiously, the company is targeting space tourism flights by 2027, with ticket prices projected to be over 100,000 USD per seat. These initiatives are not happening in isolation. Alongside technology development, China is also focusing on commercial deployment. While state-owned firms such as CASC remain powerful, recording 51 launches in 2024, their rockets are not reusable and thus cannot match SpaceX's launch cadence or cost efficiency. Reusability is the linchpin of the next-generation space economy, and Chinese private companies are racing to achieve it. Beyond launch vehicles, the boundaries between aerospace and consumer technology are beginning to blur. Smartphone makers, including Apple, are rolling out emergency satellite communication features, a signal that space capabilities are becoming embedded in everyday tech. In parallel, the military value of space, especially low-cost satellite deployment, is rising in prominence. Reusable rockets could enable the rapid replacement of surveillance or communication satellites during a conflict, giving China a strategic edge. Suborbital cargo delivery across continents is also being explored. Looking ahead, many Chinese companies envision a future that includes human spaceflight, lunar exploration, and resource extraction. While SpaceX is preparing its Starship-based HLS to support NASA's Artemis program, China has its own crewed lunar ambitions, scheduled to reach the moon before 2030. At SpaceX's Boca Chica facility in Texas, the company is aiming to produce one Starship per week, a pace far beyond any competitor today. To truly rival Musk's vision, China will not only need to master reusability and scale production, but also build an international commercial brand that inspires global partnerships and customer confidence. That's all for today's episode. Thank you so much for watching, and